All right, so we're about to start the second half of Unit 6, which will take us from lesson 6.3 all the way up to 6.6b. There's a few things that we're going to cover in here that are going to help us solve a various amount of problems, word problems, just regular math problems, whatnot. Now, if you recall what we covered for the last few lessons, we basically learned how to complete the square in order to take a quadratic relation from standard form into vertex form. And the whole point of that was so we could determine the vertex, which would then help us find the max or the min of the quadratic relation. This is great for solving all those max and min problems. Now the thing is, with every parabola, there are three key points that matter. The three key points are, of course, the vertex, which we spent the last few lessons doing, and then the x-intercepts. This tells us what is the values of x when y is exactly equal to 0. So where does it touch that x-axis? Those will help us solve different types of problems. Basically things like what is the data at the beginning and the end. Okay. So in order to do that, we are going to do something called solving the quadratic equation. A quadratic equation, we haven't learned that yet. What does that mean? Well, up to this point, we've seen data in the first form. We've seen this first quadratic here. And what we call this is what we call a quadratic expression. Just ax squared plus bx plus c. Now, when we assign that equal to y, this is what we call a quadratic relation, because we're relating the value of x, or we're specifying the value of x as how it relates to the value y, and vice versa. So this is called the quadratic relation. And this is what we've been working with so far. And this is really, really useful. But what's the quadratic equation? The quadratic equation is just the quadratic relation when the y value is exactly equal to 0. So this is the quadratic equation. What do we mean by that? What do we mean when y is equal to 0? What's so special about that? Well, think about this. If this is my parabola, and my parabola comes up here like this, and this is the x-axis, and this is the y-axis, we have our vertex way up here, y is equal to 0 everywhere on this x-axis. What are we finding here? We're finding our x-intercepts. So that's what it means to solve a quadratic equation. It means to find the values of x when y is exactly equal to 0. It means we're trying to find the x-intercepts. So solving a quadratic equation means to find the values of x that make the equation true. So what values of x will make it the right side exactly equal to 0? Okay. Make the left side exactly equal to 0 and the right side, I guess. Okay. So let's say we're starting off with our standard form quadratic relation. So this is our standard form. Y is equal to ax squared plus bx plus c. And if we want to, what we're going to do is we're going to solve our quadratic equation today by using the factored method. That means that we're going to put it in factored form. Now, if you remember, that's y is equal to a times x minus r times x minus s. And all it takes to take our equation from standard form to factored form is to factor it. We've spent the last few weeks, almost a month now, really kind of grinding out those factoring skills to hopefully cement them in there and give you a good, strong foundation. So whenever we put a problem in front of you, a standard form equation, you should be able to put it into factored form now, ideally. Now, with this, once we get it in factored form, what this is going to do is this is going to allow us to apply what we call the zero product property. Now, what is the zero product property? The zero product property is if I have A times B and the result is 0, that means either A or B or both of them have to be equal to 0, right? So if I have anything times 0, I'm going to get 0. If I have 0 times anything, I'm going to get 0. And of course, 0 times 0 is also equal to 0. So one or both of those things must be equal to 0 for the result to be 0. How is this helpful? Well, what we're going to do is we're going to find the x-intercepts. In order to find the x-intercepts, what we're going to do is we're going to take our quadratic relation and we're just going to set y equal to 0. And then we're going to determine the values that make this factor equal to 0. We're basically going to find the values of x that make this equation true. Now, how are we going to do that? We're going to do that by setting each factor equal to 0. Now look at our equation up here. We have y is equal to a times x minus r times x minus s. And we're saying instead of y here, let's put a 0. Oh, that's terrible. Let me erase that. Okay. So let's set this equation equal to 0. And what I'm saying is we can calculate the values of x by simply setting each one of these factors equal to 0. X minus r is equal to 0, and x minus s is equal to 0. Now, the clever ones of you are probably saying to yourself, whoa, 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 what about a? Should we set a equal to 0 as well? Well, we actually don't have to, because whatever the value of a is, it's irrelevant. Because if you think about it, a is just a multiplier to these two other terms. If I divide both sides by a, because currently a times these things, if I divide both sides by a, divide this by a, and divide this by a, this a's just go away, and 0 divided by a is still just 0. So really, we don't really care about the a. The only thing we care about are the two sets of factors in here inside the brackets. Now from here, we should be able to just calculate r and s, which we know from our previous units is the x-intercepts. You're like, well, I don't need to calculate that, Mr. Lane. I can just look at the brackets and I can see exactly what they are. All I have to do is flip the sign. Yeah, that's true in the simple cases. But we're not always going to be given the simple cases, are we? So let's try some of the little bit more complicated situations. So down here, I have a few examples that are going to kind of test that theory. So given the quadratic relations, we're going to set y equal to 0. And then we're going to solve each of the following values and try and find the x-intercepts. Okay, so we're going to set y equal to 0. So we have 0 is equal to x minus 5 times 2x plus 1. You're like, oh, wait, that 2x plus 1, I can't just look at it and figure out what x is going to be anymore. No, you cannot. So now we have to do the work for each one. So I'm going to take the first one, x minus 5. So I'm going to say x minus 5 is equal to 0. Well, I got x minus 5, so if I want to get rid of that 5, I got to bring it over to the other side. So to do that, I have to add 5 to both sides. So I end up with x is equal to 5. Makes perfect sense. Okay, what about the other side? What do we have over here? We have 2x plus 1 is equal to 0. So I got to bring that 1 over to the other side. So I have 2x is equal to negative 1. And now I got to divide both sides by 2 to get rid of this 2. So I end up with x is equal to negative 1 over 2. Oh, that's not as simple anymore. So we've determined the value. This is all we're doing for all of these questions. Now this one was already factored, so we didn't have to do any factoring. Yay! But we're not always going to be given quadratic relations that are already factored. So let's look at B. Now in this situation, what are we looking at? Well, we have a standard form quadratic, so we need to factor it. So we go through all of our processes. We look for a GCF, no GCF. We look for any special products, meaning a perfect square trinomial or a difference of squares. No, neither of those. We look for, is there 4 terms that we can group? No, not that. That means we had to go to our basic trinomials. So is it simple or is it complex? A has a value of 1, so it's a simple trinomial. So that means I need to find 2 numbers that add to 7 and multiply to 12. So what 2 numbers add to 7 and multiply to 12? So 1 and 12? Nope. 2 and 6? Nope. 3 and 4? Yep. 3 and 4. Now I got to figure out their signs. This is a plus. That tells me they're the same sign. And this minus tells me that they are both minus. So I have minus 3 and minus 4. So what's my equation now? Y is equal to x minus 3 and x minus 4. Now I'm going to set y is equal to 0. Okay, you can of course do this all in one step if you can get that far in your head. That's great if you can. And now I need to calculate each one and assign each one to 0. So I have x minus 3 is equal to 0. So x is equal to 3. Bring the 3 over to, minus 3 over to the other side. And over here we have x minus 4 is equal to 0. So that means x is going to be equal to 4. Bring the 4 over to the other side. And those are our 2 terms. Well, I don't know why I rotated like that, but whatever. And there we go. So we have, that's basically the process now. So for each one of these questions, I recommend that you take a minute, pause the video, and try and actually do the calculations on your own. Remember, the goal is to basically just factor. Okay, so we're going to take each one of these pieces and we're going to factor it, and then we're going to set y equal to 0 and calculate our x-intercepts. So this next one, again, we just have to do the work. So in this case, this is a complex trinomial. So two numbers that add to 19 and multiply to 60. In this case, I'm going to get 15 and 4. And they're both going to be positive, so I have y is equal to, I have to actually do decomposition here, 10x squared. And I think I'll put the 15 with the 10, so plus 15x plus 4x plus 6. And we're going to group these two, and we're going to group these two. So we have y is equal to, I should be able to take out a 5x over here, and that would leave me with 2x plus 3. And over on the other side, I should be able to take out a 2. And I'd end up with, 2x plus 3 again. And we have a matching set. So we have y is equal to 2x plus 3 times 5x plus 2. Now, I need to assign or set y is equal to 0. And 5x plus 2. I really don't have a lot of screen real estate on here, so I'm going to kind of do this to the side. I basically have to set each one of these equal to 0 now. So I have 2x plus 3 is equal to 0. I'm going to bring that 3 over to the other side. So we have 2x is equal to negative 3. Bring the 2 over by dividing both sides by 2, and we end up with x is equal to negative 3 over 2. That's our first one. And over here, I guess I'll do this one. So we have 5x plus 2 equal to 0. Bring the 2 over to the other side. And then we got to divide both sides by 5. X is equal to, that should be a negative 2. X is equal to negative 2 over 5. Okay. So far, so good. All right, let's go to the next one. This one is not factored yet, so we have to factor it. But nice, this one is actually a difference of squares, so that makes life a little bit easy here. So y is equal to x plus 3 times x minus 3. Great. And now I need to set y is equal to 0. X plus 3 times x minus 3. And I need to set each one equal to 0. X plus 3 is equal to 0. X is equal to minus 3. And similarly on the other side, we have x minus 3 is equal to 0. That means x is equal to positive 3. All right, we're just rocking through these things now. So if we scroll down a little bit, let me just move my little graph here. So this next one, a has a value of negative 1. So I have a couple choices here. I could actually do a complex trinomial, or the better choice would be to factor out that negative 1 from each term. So we'd end up get our greatest common factor, negative x squared minus 7x plus 10. So I need to find two numbers that add to 7 and multiply to 10. And in this case, 1 and 10, nope. 2 and 5, yep. And in this case, they're both the same sign and they're both negative. So negative 2 and negative 5. So this is a simple trinomial. Y is equal to negative x minus 2 and x, it's negative over there, x minus 5. Okay. I don't have to do anything special other than set y is equal to 0. And now I need to assign each one of the terms equal to 0. Now remember, we don't have to do anything with the negative 1 because we could just divide both sides by negative 1 and get rid of it anyway. So since there's a 0 on the left. So we don't have to worry about it. We just go right into it. So we have x minus 2 is equal to 0 and x minus 5 is equal to 0. Now we calculate. Bring the 2 over to the other side. We end up with just x is equal to 2. And on the other side, we have x. Bring the 5 over to the other side. We have x is equal to 5. Not bad. We got one more example here. So in this one, we can factor out not much. We can just take out a greatest common factor. So we could just say y is equal to 2x, and then we have x minus 4 on the inside. Now, most of you are probably thinking, well, how do we go about solving this? those are still two factors. This is not the a term. This is the other term. This is like 2x plus 0 basically is what we're looking at here. So we need to set each one of these terms equal to 0. So we have 2x is equal to 0. That was terrible handwriting, so I'm going to rewrite that. There we go. We have 2x is equal to 0. And over here we have x minus 4 is equal to 0. So 2x equals 0. I have to divide both sides by 2. So we end up with just x is equal to 0. That's a perfectly valid x-intercept. In fact, we normally get that one quite often when we were doing our previous lessons. So now we have x minus 4 is equal to 0. We just got to bring that x over to the other side. We end up with x is equal to 4. And there we go. So that's the basics of everything that we're doing this unit, this lesson, is just factoring and then setting y equal to 0 and calculating the result. Nice. Okay, so let's apply this knowledge a little bit. Now this question is telling us, let's write a quadratic relation in factored form. So we know that we're looking to get y is equal to a times x minus r times x minus s. It tells us that it tells us the x-intercepts. It tells us r and s. Nice. That makes life a lot easier now, doesn't it? So if we think about this, we already know how to do that. So we can just substitute those values right into our equation. So y is equal to, so if this is r and this is s, y is equal to a times x minus negative 3. Now, we can look at that and we know exactly what that's going to be, but let's keep going. And then we have x minus 5. I'm going to fix this up because we know minus a negative is the same thing as plus. So that's y is equal to a times x plus 3 and x minus 5. Now, most of you probably saw that immediately and didn't even do that middle step. Great. Continue doing that. That's awesome. Mental math is the best math. Okay, but we're not done because we don't know the value of a. Now, we're going to follow the exact same process we've done for the last 2 units in order to find a. We have an equation and we have another point. All we have to do is sub that point in for x and y, and the only variable left is going to be a. So we can just calculate it. Okay, so we're going to sub our 1 comma negative 8 into, let's call this equation 1, just so we have a simple label for it, into equation 1. Alrighty, so we have y, which is going to be negative 8, is going to be equal to a, which is what we're trying to solve, and then x is 1 plus 3 times 1, minus 5. Let's just do our basic math here. Negative 8 equals a times 4 times 1 minus 5 is negative 4. That means we have negative 8 is equal to 4 times negative 4 is negative 16. Negative 16a. So I have to divide both sides by negative 16 to get rid of it and isolate for a. So negative 8 divided by negative 16. Oh, that's just 1/2. Nice. So that means a is equal to 1/2. Therefore, y is equal to 1/2 times x plus 3 times x minus 5. Now, this is a pretty standard type of question to get. Now, the numbers in this one were super simple. Let's try the same question, but this time with slightly more challenging numbers. So again, we're going to write a quadratic relation in factored form. We know it's x-intercepts. Okay, so we know that one of the x-intercepts is at negative 1 over 2, and the other one is at 3 over 5. Now you're thinking, oh, that's just r and s. Yeah, but we want to clean that up quite a bit. We also know a third point, the y-intercept. Y-intercept. So that means this point. What is this point? That means it's the y-intercept. It means it's touching the y-axis. So that means that x has to be 0 in order for that to be touching the y-axis. So this point is 0, negative 9. So we have our third point. So we need to be able to calculate r and s in a more simple approach. Basically, what we need to say is we know that this is an x-intercept. So we can just say, well, x is equal to negative 1 over 2. And over here, we know that x is equal to 3 over 5. Well, let's make this a bit better of a looking equation, because what we want to do is we want to get it into the same form of x minus r and x minus s. But we know that these are x-intercepts, right? So this is when x is equal to 0. Oh. So we're going to bring our data over and simplify this math. So first thing I want to do is I want to get rid of this 2 on the bottom. So I'm being divided by 2 right now. So in order to get rid of this 2, I need to multiply both sides by 2. So that gives me 2x is equal to negative 1. Now I got to bring over this negative 1. So I'm going to add 1 to both sides. So that's 2x plus 1 is equal to 0. Ah, that's what we were looking for. If you look at in the previous questions above, that's basically what our goal was this entire time. This is where we started, something like this. X minus 5 is equal to 0. Or a better example might be this one over here, 5x plus 2. 5x plus 2 is equal to 0, and eventually broke it down into what x is equal to. We're going the opposite direction this time. We need to get this factor. Remember, our goal is to get the factor. We already have the x-intercept. We want to get the factor that creates that x-intercept. And that's what we're doing here. We're trying to solve and get 0 on one side. Okay? So in this first one, we multiplied both sides by 2. So multiplied both sides by 2. In this one, we added 1 to both sides. Now we can do the same thing for the other term over here. Remember, we're trying to get it into the factor. So I want to get this equal to 0 by the time I'm done. So in this first step, I'm going to multiply both sides by 5 because I got to get rid of the 5 on the bottom. So that means we're going to end up with 5x is equal to 3. Now I got to get rid of this 3 right here, which means I need to subtract 3 from both sides. So that's going to become 5x minus 3 is equal to 0. So that is what we're actually trying to work with here. So if we write out our equation, we have y is equal to a, which who knows what that is, times our first term, which is 2x plus 1, times our second term, which is 5x minus 3. Great. And now we just need to solve for a. How do we do that? The same way we've been doing the other time. Just substitute our value in. So let's call this equation 1. We're going to sub 0, negative 9 into equation 1. Okay. Let me just make sure all of my math is still checking out. I think this is good. Okay. So that means y is negative 9 equals a, which is what we're trying to solve. And then inside brackets, 2 times 0 plus 1. And then the next set of brackets, 5 times 0 minus 3. Okay. Negative 9 equals a times, well, 2 times 0 is 0 plus 1. So that's just 1. Multiplied by 5 times 0 is just 0 minus 3 is minus 3. So we have negative 9 is equal to negative 3a. So we're going to divide both sides by negative 3. Negative 9 divided by negative 3 is just 3. So that means a is equal to, oh, that's a big A. It almost looks like a 9. Better fix that. Our a is equal to 3. Therefore, our final equation, y is equal to 3 times 2x plus 1 times 5x minus 3. So it's a much more complex equation than we had in the previous question. Okay, so let's apply this knowledge to an actual word problem now. Now remember, with word problems, your first step should be drawing a picture the best you can. Okay, so we have a ball thrown from the top of a cliff. The ball from the top of a cliff. So let's imagine that this is our cliff. And it's getting thrown from here. Where's it getting thrown into? Its height is h in meters. So let's assume that our y-axis is our height in meters. Above the sea. Oh, I guess he's throwing it into the sea. Here's my water. Beautiful water. Okay. So that means that he's throwing it from the cliff. And it's going to make its way and splash down into the sea. Splash, 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 splash. Okay. After t seconds. Ooh, t, that means our x-axis is our time. And this is measured in seconds. So our height is in meters. And our time is in seconds. Okay. So if you think about what this is This is really just a graph. There's 0, 0 down there. Now it says that this whole thing can be modeled by the relation h is equal to negative 5t squared minus 25t plus 120. How long will it take for the ball to land in the water? What is it actually asking us? It's asking us, what is t when h is equal to 0? So what is it asking us? It's asking us for the x-intercepts. So it's saying, what is t when h is equal to 0? Now, for those of you that remember how parabolas work, in theory, this parabola would continue down in this direction and would also hit 0 back here somewhere. But of course, that's through the cliff, and we know that that isn't really what we care about in this question. We only care about where it hits the water. But we have to realize that every parabola, as long as the vertex is not on the x-axis, will have 2 x-intercepts. Of course, if it's not on the x-axis and it's opening towards the x-axis, I should say. Alrighty, so we're given our equation. Our job is to find the x-intercepts. Well, we just learned how to do that. We're going to factor this thing, and then we're going to set each term equal to 0 to figure out what the value of t is. All right, so let's start off with our whole equation. H is equal to negative 5t squared, minus 25t plus 120. All righty, so let's factor it. What can we factor out first? Well, clearly there's a greatest common factor of negative 5 here. So let's get rid of that. So h is equal to negative 5 times t squared plus 5t, signs are flipped because I factor out a negative 5, minus 120 divided by 5 is 24. Okay. Now, we got to look at that, and clearly it is not a special product or anything like that. So that means we have to do straight up regular old factoring. This is a simple trinomial, so we just need to know two numbers that add to 5 and multiply to 24. So 1 and 24 ain't going to do it. 2 and 12 ain't going to do it. 3 and 8, yep. 3 and 8 will definitely do it. So we have 3 and 8. This minus sign tells me that they are not the same sign, though. This plus sign tells me the bigger of the two numbers is positive. Oh, right there. So that means that the 3 is a negative. So we write our next line. H is equal to negative 5, and we have t minus 3 times t plus 8. Okay, so we've got to the point where we have our factored form. Now we need to calculate the x-intercepts by setting the whole equation equal to 0. So now it's a quadratic equation, not a quadratic relation anymore. So we have negative 5, t minus 3, and t plus 8. Now our job is to calculate. So on this side, we have t minus 3 is equal to 0. Over here, we have t plus 8 is equal to 0. So let's calculate. So in this case, we have t is going to be equal to, bring the minus 3 over to the other side, we end up with just 3. So that's t is equal to 3 seconds. Over here, we have t is equal to, bring the 8 over the other side, we end up t is equal to negative 8. Negative 8, time negative 8? What is going on here? Well, what is happening is the other side of this picture. What it's telling us is that in reverse time, basically, if we kept following the parabola, we would end up at negative 8 seconds, which is where it would also have a height of 0. Now, of course, that doesn't make any sense in the context of our question. So it's our job to reject impossible answers. So we are going to reject this response because it's impossible. So our t is equal to 3 is our correct answer. So therefore, it will take 3 seconds for the ball to hit the water. Okay, So that's it for this portion of the lesson. And basically just to summarize really quick, what we did is we took a standard form equation, we factored it into factored form. And then we simply set our factored form quadratic relation equal to 0, making it a quadratic equation. And from that, we were, actually, I guess it's technically not a quadratic equation. It is an equation, though. And from that, we were allowed to use the rule, which we called the zero product property, that allows us to set each term equal to 0 and calculate what those x-intercepts are. And that allowed us to solve various problems, whether that was to come up with another equation, whether that was to solve some kind of word problem. Now remember, this type of solution is meant for determining or solving problems that need x-intercepts. The previous lessons were all about determining a solution for problems that needed a vertex, a maximum or a minimum. So based on the types of questions you see going forward, if you need a maximum or minimum, you need to put it in vertex form using completing the square. If you need to solve for an x-intercept, then you need to put it into, you need to use the strategies that we're using for the rest of the unit here, which are going to allow us to find the x-intercepts. Awesome. So that's it for today. See you on the next one.